Have you ever looked at the Great Pyramid of Giza and wondered whether the story we've been told is actually complete? For generations, we've accepted that this enormous monument was built using simple tools, human determination, and years of relentless labor. But what happens when every known fact, every archaeological report, every engineering study, and decades of research are examined together without human bias? Recently, researchers began exploring that very question with the help of advanced artificial intelligence. Instead of asking it to invent wild theories, they gave it one simple task: analyze the available evidence and compare it with the explanations we've accepted for centuries. The expectation was straightforward. The system would likely confirm what history books have been saying all along. Instead, something unexpected happened. Rather than pointing toward science fiction or extraordinary visitors from another world, the analysis highlighted something far more unsettling. It exposed the difference between what we confidently claim to know and what the available evidence can actually prove. That distinction changes everything. For more than 4,000 years, the Great Pyramid has dominated the Giza Plateau, standing as one of humanity's greatest engineering achievements. Millions of visitors admire its size, but very few stop to ask the question that continues to challenge historians, engineers, and archaeologists alike. How was it really built? Traditional explanations tell us that skilled Egyptian workers, equipped with copper tools, wooden sledges, ropes, and remarkable organization, constructed the monument block by block. It's an impressive story, and much of it is supported by archaeological discoveries. Yet when experts examine the finer details, the picture becomes less certain. The Great Pyramid isn't simply massive. It's astonishingly precise. Its four sides are aligned almost perfectly with true north. The foundation remains incredibly level across an enormous area. More than 2 million stone blocks fit together with a level of accuracy that still surprises modern engineers. These aren't disputed facts. Researchers from different fields generally agree on the measurements. The mystery begins when we ask exactly how those measurements were achieved using the technology believed to exist more than 4,500 years ago. And that's where the real investigation starts. At first glance, everything appears to make sense. Ancient Egypt possessed skilled craftsmen, organized labor forces, and generations of construction experience. Over decades, historians have uncovered workers' villages complete with homes, bakeries, medical facilities, and even burial sites, proving that the pyramid builders were not enslaved laborers, as many once believed. Instead, they were respected workers participating in one of the largest state projects of the ancient world. That discovery solved one long-standing myth, but solving one mystery revealed another. Because even after identifying who built the pyramid and roughly when it was constructed, one question remains stubbornly unanswered. Exactly how did they accomplish something this extraordinary? The deeper researchers looked into the numbers, the more unusual the situation became. The Great Pyramid is believed to contain roughly 2.3 million stone blocks. Most weigh between 2 and 3 tons, while some of the largest granite pieces inside the King's Chamber reach well over 60 tons each. Even today, moving objects of that size requires detailed planning, specialized equipment, and careful coordination. Yet the ancient Egyptians managed to do it thousands of years ago. Even more impressive is the pyramid's precision. The structure is aligned with the cardinal directions so accurately that the margin of error is incredibly small. Modern surveyors equipped with advanced instruments appreciate just how remarkable that level of accuracy really is. So the obvious question isn't whether the Egyptians built it. The archaeological evidence strongly suggests they did. The real mystery is understanding exactly how they achieved such astonishing precision with the tools available at the time. Researchers have proposed several possible methods over the years. Some believe enormous straight ramps were built to drag the stones upward. Others argue that spiral ramps wrapped around the pyramid as it grew taller. More recent theories even suggest that hidden internal ramps may have been constructed inside the monument itself. Each explanation solves certain problems. but each also creates new ones. For example, a massive straight ramp would likely have required an extraordinary amount of material, possibly rivaling the pyramid itself in size. If such a structure existed, where did it go? Why has no clear archaeological evidence of such an enormous ramp ever been discovered? Spiral ramps present another challenge. While they reduce the amount of material needed, they would have made it difficult for builders to maintain the incredible alignment and symmetry visible throughout the monument. The corners of the pyramid would have been hidden during construction, making precise measurements far more difficult. Then there is the internal ramp theory. Many engineers consider it one of the more elegant ideas because it explains how workers could continue raising stones without constructing gigantic external ramps. Interestingly, some modern scans have detected unusual internal features that appear consistent with this possibility. But there is an important distinction. Consistent doesn't mean confirmed. That's what makes the Great Pyramid so fascinating. No single construction theory has been universally accepted because none fully explains every detail of the monument. The further experts investigate, the more they realize that several important pieces of the puzzle are still missing. And perhaps the biggest challenge of all lies hidden inside one specific room, the King's Chamber. Because once attention shifts toward the enormous granite blocks forming its ceiling, the mystery becomes even harder to explain. Those blocks weren't quarried nearby. They originated hundreds of kilometers away in Aswan, meaning they first had to be extracted, transported across long distances, and then lifted more than 40 meters into the air with extraordinary precision. Moving one stone of that size would be an incredible achievement. The Egyptians repeated the process again and again. Not once, not twice, but for every massive granite beam placed inside the chamber. That level of organization suggests something remarkable, not supernatural, but incredibly sophisticated. It points to a civilization whose engineering abilities may have been far more advanced than we often imagine. Yet despite decades of research, no one has demonstrated the complete step-by-step process beyond reasonable doubt. The stones are still there. The evidence is still there. But the full method remains one of history's greatest unanswered engineering questions. The mystery becomes even more intriguing when researchers focus on the granite itself. Unlike the limestone used for much of the pyramid's outer structure, the massive granite blocks inside the King's Chamber came from quarries near Aswan, hundreds of kilometers south of Giza. Transporting material over such a distance would have required careful planning, remarkable coordination, and an efficient transportation network. Historical evidence suggests that the Egyptians used boats along the Nile to move many construction materials. One of the most significant discoveries supporting this idea came from ancient papyrus records describing officials responsible for transporting limestone to Giza. That discovery strengthened the traditional explanation, but it didn't solve everything, because limestone and granite are very different challenges. Some of the granite beams weigh between 40 and 70 tons. Moving cargo of that size safely across rivers, unloading it without damage, dragging it over land, and finally raising it more than 40 meters into the air would have pushed any ancient engineering system to its limits. And this wasn't an isolated achievement. The same process had to be repeated multiple times with extraordinary consistency. That's the detail many discussions overlook. It's not simply about moving one enormous stone. It's about developing a reliable system capable of repeating the task again and again without catastrophic failure. This is where modern engineering still struggles to provide one universally accepted explanation. Several methods appear possible. None has been conclusively demonstrated. Rather than proving the Egyptians couldn't have done it, this simply reminds us that an important part of the construction process has yet to be fully reconstructed. Modern technology has only made the puzzle even more fascinating. Instead of drilling into the monument or dismantling ancient walls, scientists now use techniques that allow them to study the pyramid without damaging it. One of the most remarkable methods is muon tomography. Cosmic particles constantly pass through Earth and even through solid stone. By placing highly sensitive detectors around the pyramid, Researchers can measure how these particles travel through the structure, revealing hidden empty spaces deep inside without removing a single block. When this technology was applied to the Great Pyramid, it produced a surprising result. A previously unknown void, stretching roughly 30 meters, was discovered above the Grand Gallery. For centuries, countless explorers believed the monument had already revealed all its major secrets. Yet one of its largest hidden spaces remained unnoticed until modern physics uncovered it. A few years later, researchers confirmed another previously unknown corridor near the northern entrance. These discoveries remind us of something important. Even after centuries of study, the Great Pyramid is still capable of surprising the scientific community. Far from being a solved mystery, it continues to reveal new details with every generation of technology. Artificial intelligence is now helping researchers organize enormous amounts of archaeological data, engineering models, structural simulations, and historical research far more efficiently than any single person could. Interestingly, the AI didn't conclude that aliens built the pyramids. It didn't discover evidence of lost civilizations with impossible technology. Instead, it pointed toward something much more reasonable, and perhaps even more profound. It highlighted the gaps between established explanations and the evidence currently available. In other words, humanity may not have the complete answer yet. And perhaps that's the greatest lesson of all. The Great Pyramid doesn't challenge us because it's impossible. It challenges us because it reminds us how much ancient knowledge has been lost over time. Every new scan, every archaeological discovery, and every engineering study adds another piece to the puzzle. But the full picture still remains just beyond our reach. As researchers continued examining the Great Pyramid, another mystery quietly emerged. One that had nothing to do with its enormous size and everything to do with its extraordinary precision. From a distance, the monument appears rugged and weathered. But thousands of years ago, it looked completely different. Originally, the pyramid was covered with brilliant white limestone casing stones, carefully polished until they reflected sunlight across the surrounding desert. Ancient travelers may have seen it shining from many kilometers away, almost like a giant beacon rising from the horizon. Most of that smooth outer layer disappeared over the centuries, reused in later construction projects. Fortunately, a few casing stones remain, allowing modern surveyors to study the craftsmanship firsthand. What they found was astonishing. The gaps between many neighboring stones measure only fractions of a millimeter. Think about that for a moment. Each block weighs several tons, yet they were fitted together with incredible accuracy. In many places, the joints are so narrow that inserting even a thin sheet between them would be extremely difficult. That level of precision isn't easy to achieve even with modern machinery. Ancient builders also used a thin layer of mortar between many of the blocks. Interestingly, the mortar wasn't simply poured into large gaps to hide mistakes. Instead, it appears to have been applied with remarkable consistency across carefully prepared stone surfaces. This suggests that the builders weren't correcting poor workmanship. They were refining already precise construction. Modern engineers often point out that producing one perfectly fitted stone is impressive. Producing hundreds is extraordinary. Producing thousands across one of the largest monuments ever built becomes something entirely different. Every stone had to fit within a carefully planned design. A mistake made near the foundation could affect the alignment of everything built above it. Yet the pyramid maintained its remarkable geometry from the first course of stones all the way to its summit. This raises an obvious question. How did ancient craftsmen repeatedly achieve such accuracy without lasers, steel cutting equipment, or modern measuring instruments? No one doubts their skill. The uncertainty lies in understanding every step of their process. Some researchers believe generations of practical experience allowed Egyptian builders to master techniques that later civilizations gradually lost. Others suggest that construction methods became more refined over centuries through continuous experimentation. Both explanations are possible, but neither completely fills every gap in the historical record. That uncertainty has encouraged scientists to look beyond traditional archaeology. Instead of relying only on ancient artifacts, researchers now combine engineering simulations, geological analysis, computer modeling, and advanced imaging technologies to study the monument from entirely new perspectives. And those technologies have begun revealing details that previous generations never had the opportunity to see. For centuries, studying the Great Pyramid meant relying on what researchers could physically see. Every chamber, passageway, and corridor had to be explored by entering the structure itself. Naturally, many experts believe that after hundreds of years of investigation, the pyramid had already revealed nearly all of its secrets. That assumption didn't last. In the last decade, scientists introduced a completely different approach, one that doesn't require breaking through walls or removing a single stone. Instead, they turned to muon tomography, a technique borrowed from particle physics. Muons are tiny particles created when cosmic rays collide with Earth's atmosphere. These particles constantly pass through buildings, mountains, and even our own bodies. Because they interact differently with solid rock and empty space, researchers can use specialized detectors to map hidden areas inside massive structures. Think of it as creating an X-ray of an entire pyramid. When international teams placed these detectors around the Great Pyramid, the results surprised almost everyone. The scans revealed a massive hidden void, stretching roughly 30 meters above the Grand Gallery. This wasn't a forgotten treasure room or evidence of an ancient legend coming to life. It was a real architectural space that had remained unknown for more than 4,000 years. The discovery demonstrated something incredibly important. Even the world's most studied ancient monument can still hold major surprises. Years later, researchers identified another previously unknown corridor near the pyramid's original northern entrance. Although relatively small compared to the larger void, its discovery reinforced the same message. There are still parts of this monument that we don't fully understand. Every new finding forces historians and engineers to revisit ideas that were once considered settled. This is exactly where modern computer technology has become so valuable. Researchers now create highly detailed three-dimensional digital models of the entire pyramid. Every block, passageway, and chamber can be reconstructed inside powerful computers, allowing engineers to test different construction methods without ever touching the original structure. They simulate ramp systems. They analyze weight distribution. They calculate structural stresses. They compare thousands of possible construction scenarios. Instead of relying only on imagination, they can now evaluate which ideas actually work according to the laws of physics. Artificial intelligence plays a growing role in this process. Rather than replacing archaeologists, AI helps organize enormous collections of research that would take humans years to review manually. It compares engineering studies with archaeological discoveries. It identifies patterns hidden across thousands of scientific papers. It highlights inconsistencies that deserve closer investigation. Most importantly, it separates speculation from measurable evidence. Interestingly, this careful analysis doesn't point toward mysterious civilizations or supernatural explanations. Instead, it reaches a much simpler conclusion. Some parts of the accepted construction story are strongly supported by evidence. Other parts remain educated hypotheses that still require additional proof. That distinction is easy to overlook. Over time, repeated theories often begin sounding like established facts. But science works differently. Every explanation must continue to stand up against new evidence. And every new discovery has the potential to improve or completely reshape our understanding of history. The Great Pyramid reminds us that learning never truly stops. Even after centuries of research, it continues asking questions that modern science is still trying to answer. As new discoveries continued to emerge, one pattern became impossible to ignore. The Great Pyramid wasn't becoming less mysterious. It was becoming more fascinating. Every generation of researchers seemed convinced they were finally close to solving its greatest secrets. Yet each breakthrough uncovered another layer of questions waiting beneath the surface. That is exactly what happened when artificial intelligence entered the conversation. Contrary to sensational headlines across the internet, AI didn't suddenly reveal a hidden civilization or prove that impossible technology existed thousands of years ago. Instead, it did something far more valuable. It reviewed enormous collections of archaeological reports, engineering calculations, geological surveys, structural analyses, and historical records without being influenced by long-held assumptions. Rather than asking, which theory sounds the most exciting? It asked a much simpler question. Which explanations are fully supported by evidence, and which ones still contain unanswered gaps? That difference matters, because history is filled with examples where widely accepted ideas were later corrected after new discoveries came to light. For decades, many believed the pyramids were built by enslaved workers. Then archaeologists uncovered workers' villages, burial grounds, and evidence of organized labor, completely changing that narrative. Later, many experts believed the pyramid's interior had already been fully explored. Modern scanning technology proved otherwise by revealing hidden spaces no one had previously detected. Again and again, confidence gave way to new evidence. That doesn't mean previous researchers were careless. It simply reflects how science evolves. Every answer remains open to revision when stronger evidence appears. Artificial intelligence reinforces this scientific approach. It doesn't become attached to traditional theories. It doesn't defend popular opinions. Instead, it continuously compares available evidence with proposed explanations, highlighting places where the data doesn't completely match the conclusions. This doesn't weaken archaeology. It strengthens it. By exposing uncertainties, researchers know exactly where future investigations should focus. Perhaps an overlooked quarry contains new clues. Perhaps another hidden corridor still waits inside the monument. Or perhaps future technology will reveal construction details that today's instruments cannot yet detect. Whatever the answer may be, one thing is becoming increasingly clear. The Great Pyramid still has stories left to tell. It continues challenging engineers. It continues surprising archaeologists. And it continues reminding humanity that even our greatest achievements in science have not answered every question about the ancient world. Maybe that's the real lesson hidden within its massive stone walls. Not that ancient people possessed magical technology. Not that history is wrong, but that extraordinary human ingenuity often exceeds the limits of our modern imagination. Sometimes the greatest mystery isn't how impossible something seems. It's how capable ordinary people can become when knowledge is refined across generations and a civilization dedicates itself to achieving something truly extraordinary. And perhaps that's why the Great Pyramid still captures our attention today. Because every new discovery doesn't close the case. It simply opens the door to the next question. So, after examining decades of research, advanced engineering models, and the latest scanning technologies, what is the biggest conclusion? Ironically, it isn't the dramatic answer many people expected. Artificial intelligence didn't uncover proof of aliens. It didn't discover evidence of a forgotten super-civilization with impossible machines. Instead, it exposed something much more thought-provoking. It highlighted how often humans confuse confidence with certainty. For generations, textbooks presented many pyramid theories as settled facts. Over time, those explanations became so familiar that few people stopped to question whether every detail had actually been proven. But history has a habit of surprising us. Every time researchers believed the mystery was finally solved, new discoveries forced them to reconsider their conclusions. That pattern has repeated itself again and again. Not because scientists were trying to mislead anyone, but because science is constantly evolving. Every generation works with the best evidence available at that moment. When better evidence appears, the story naturally changes. The Great Pyramid is one of the clearest examples of that process. Early historians believed enslaved workers built it. Modern archaeology revealed organized communities of skilled laborers who were fed, housed, and respected for their work. Researchers once assumed every major chamber inside the pyramid had already been discovered. Modern particle scanning technology later identified hidden spaces that remained unknown for thousands of years. Even long-accepted construction theories continue to be debated as engineers test them using computer simulations and structural analysis. None of this weakens history. It strengthens it. Real science doesn't fear being corrected. It welcomes better evidence. This is exactly where artificial intelligence offers something valuable. Unlike humans, it has no emotional attachment to older theories. It doesn't care who first proposed an idea. It doesn't consider reputation or popularity. It simply compares data. If measurements support an explanation, the model recognizes it. If gaps remain, those gaps become impossible to ignore. That doesn't mean AI has all the answers. Far from it. Its greatest strength is identifying questions that deserve closer investigation. Instead of declaring, "This is exactly how the pyramid was built," it points toward the places where our understanding is still incomplete. And surprisingly, those unanswered questions are what make the Great Pyramid even more remarkable. The monument isn't becoming less impressive as science advances. It's becoming more extraordinary. Every new technology reveals another layer of complexity hidden beneath its massive stone blocks. Every discovery reminds us that ancient civilizations were capable of achievements we are still working to fully understand. Perhaps that's the most important lesson of all. Sometimes history doesn't become smaller as knowledge grows. Sometimes it becomes even greater than we ever imagined. But perhaps the most fascinating discovery has nothing to do with hidden chambers or advanced technology. It has everything to do with how we view the people who came before us. For a long time, many assumed that ancient civilizations were primitive simply because they lacked modern machines. We often judge the past by comparing their tools to ours. But history doesn't work that way. Simple tools don't automatically mean simple minds. The builders of the Great Pyramid weren't experimenting by chance. They inherited centuries of accumulated knowledge. Every generation passed practical experience to the next, improving methods, refining techniques, and solving problems long before written engineering manuals ever existed. By the time Pharaoh Khufu's pyramid was planned, Egyptian builders had already completed impressive stone monuments for generations. The Step Pyramid of Djoser had demonstrated that large-scale stone construction was possible. Each major project became a lesson for the next, allowing craftsmen to perfect their understanding of quarrying, transportation, measurement, and structural design. Knowledge wasn't stored in computers. It lived in experienced hands. Master builders trained apprentices. Stone cutters passed their techniques to younger workers. Surveyors perfected their methods through years of observation, using the stars, the sun, and simple measuring tools with astonishing precision. To modernize, those instruments may appear basic, yet in skilled hands, they produced one of the greatest engineering achievements in human history. Perhaps that's what surprises us most. Not that the Egyptians built something extraordinary, but that ordinary human intelligence, patience, and organization were capable of accomplishing something we still admire over 4,000 years later. The internet often searches for dramatic explanations because they're exciting. Aliens, lost civilizations, secret machines. But sometimes the real story is even more inspiring. A civilization that carefully refined its knowledge over centuries may accomplish things that later generations struggle to fully recreate. Not because the methods were magical, but because much of that practical experience gradually disappeared with time. History is filled with examples like this. Ancient techniques for working stone, producing certain materials, or constructing massive monuments have often been lost, rediscovered, and improved centuries later. The Great Pyramid may simply be the most famous example. Every unanswered question reminds us of something important. There's a difference between saying, "We don't fully know how they did it," and saying they couldn't have done it. Those are not the same statement. The first reflects scientific honesty. The second is merely an assumption. And as history has repeatedly shown, assumptions have a habit of being overturned by new evidence. Maybe the greatest mystery isn't hidden inside the pyramid at all. Maybe it's hidden in our tendency to underestimate the people who came before us. Because every new discovery points toward the same remarkable conclusion. Ancient civilizations may have understood far more than we once believed. And perhaps we've only begun uncovering the true extent of their achievements. So where does all of this leave us? After centuries of exploration, countless archaeological expeditions, modern engineering studies, and some of the most advanced scanning technologies ever developed, one truth continues to stand above everything else. The Great Pyramid refuses to give up all of its secrets. Every generation believes it is closer than the last to solving the mystery. And yet, with every breakthrough, another question quietly appears. That isn't a failure of science. It's exactly how real discovery works. Knowledge doesn't move forward by pretending every answer is already known. It advances because people are willing to challenge assumptions, test new ideas, and follow the evidence wherever it leads. Perhaps that's the most valuable lesson hidden within the stones of Giza. The pyramid isn't asking us to believe impossible stories. It's asking us to remain curious. Because curiosity has always been humanity's greatest tool. Thousands of years ago, skilled builders transformed millions of stone blocks into one of the most recognizable structures ever created. Today, scientists, engineers, archaeologists, and historians continue building something of their own, not with limestone and granite, but with evidence, research, and technology. Each discovery becomes another stone added to humanity's understanding of the past. And that work is far from finished. Artificial intelligence will continue analyzing data. Engineers will continue testing new construction models. Archaeologists will continue uncovering forgotten sites. Physicists will continue scanning areas no human eye has ever seen. With every new advancement, our understanding grows a little clearer. But perhaps the greatest surprise waiting ahead won't be a hidden chamber or a forgotten treasure. It may simply be a better understanding of the remarkable people who built this monument in the first place.